In this video, I'm going to continue modeling an HVAC system based on system analysis report that was generated in part 1 after setting up energy settings. After generating the report, I need to go to my plan view and set up zones. I'm trying to stay consistent with zone naming, so I will name this SZ0 for sales area, select the space and then click OK. Notice that there is a thicker perimeter around sales space that tells me that the space is under that particular zone. Now I will click on zone again and select pharmacy space. This will be SZ1. And lastly, I need to group all these spaces in SZ2, so I'm going to pick each one of them, and this zone will be the most useful because I will be able to use it to double check if the equipment meets cooling and heating loads and delivers enough airflow to service all these spaces. Next, I will go to View and create a space schedule. Here I'm going to add the following: name, number, zone, specific supply airflow, specific return airflow, actual supply airflow, actual return airflow, design cooling loads, design heating loads, actual cooling load, actual heating load. Now I will sort by zone and check header and footer and then sort by name. Also, I need to choose totals only for zone. Next, I will go to formatting and select specified airflow and make sure it is set up to calculate totals. I will do the same for supplied return airflow, and if I can click on actual supply airflow and hold Ctrl and Shift on my keyboard, I can select all these parameters all the way to the bottom and set all of them to calculate totals, and then I hit OK. Since the schedule is already grouped by zones, I do not need zones column, so I can choose to hide it. We will see the purpose of the schedule in a minute. First, I want to set up analytical spaces schedule to further help me with my design. I do not need the count, so I will remove it. I want to add peak cooling load, peak heating load, and airflow per area. I already have area parameter in my schedule, but I need to find out how many cubic feet per minute I need for each area. Note that cubic feet per minute parameter has been calculated by Revit after we ran Create Energy Model and Energy Settings. To do that, I will do a calculated parameter with the name Calculated Airflow. For discipline, I will choose HVAC. I'm not going to touch the type, and here on formula I can pull the parameters, which are area times airflow per area, and then hit OK twice. In this schedule there are a lot of spaces called analytical spaces. These are the spaces that were grouped under unconditioned, which were unoccupied areas like plenums. I don't care about these spaces, so I'm going to filter this schedule to exclude them by using does not contain and then type analytical space. Now this schedule has the spaces I need to focus on, and I can use airflow and peak cooling and heating loads to design my system. An easy way to do this is if I drag this schedule window here on the right side to split the working area in two. What I also like to do is to go to Appearance and check Stripped with a light gray shade, so it makes it easier to follow the rows. The information in this schedule on the right side, called Analytical Spaces, was generated when I ran an energy model which has been created based on the energy settings. If I delete the energy model, all these parameters will be gone. I'm going to transfer the information from the right schedule to the left schedule. For example, storage space has a calculated airflow of 971 cubic feet per minute. I'm going to transfer this value to storage space in the left under specific supply and return air. Also, I need to transfer peak cooling and heating from the right to design cooling and heating on the left. I will fast forward while I do the same for each space. The reason why I created the space schedule is because now I have a specified value, which is what I need for a space, and then an actual value. The specified value is pulled from the energy model, while the actual value column cannot manually be modified. It will be filled up as I go along and model my HVAC system components in my 3D model. Let's see how that works. I need to go back to my ceiling mechanical plan. Also, I want to load a different terminal family, and I can find it in mechanical folder. I want to use supply diffuser with rectangular face with round neck. I can use air terminal command, and since I already know my ceiling is at 15 feet, I need to set the air terminal elevation to 15 feet, and I know from my analytical space schedule that in the cell space I need 3863 cubic feet per minute according to my energy model analysis. So I will probably need around 5 terminals, out of which 4 of them will be 800 CFM. Also from the type selector I can choose a 24 by 24 with 8-inch round neck, and I guess I need to set up elevation again. So I'm going to randomly place them in the sales area, and I'm not going to pay too much attention to the position. I just want to make sure I have them all in the sales area ceiling. Let me at least pull a dimension between each one of them so I can at least space them at equal distance. So what happened after I placed these terminals? Let's go back and look at the space schedule. I will drag it here to the right. As I can see, the actual supply airflow has been updated and I have 2500 CFM for the sales space. I was expecting to have 4000 CFM, but I guess that when I changed the type of the air terminal, I did not update the CFM to 800 for each terminal. So I'm going to hold my control key and select these terminals. In the properties panel, I can now change flow value to 800 each, and notice that now actual supply airflow has been updated to 4000. This is more than I need for this space, so I will update the flow on this bottom terminal to 665. All this should cover the demand for supply airflow. Now I need the return, and Revit does not have the same family I just used for the return, but I can always go to edit type. Now I can select the connector. I just need to make a couple of changes. Flow direction needs to be changed to out instead of in, and system classification has to be set to return air. Also, I need to change the annotation in the reference view, and I can just remove one of these diagonal lines. I want to save this family with a different name. I will just replace the word supply with the word return. Now I can hit load and close to use it in my project. The same way I did for the supply airflow terminal, I need to set the elevation for the return terminal, the flow value, and the type. I guess the type needs to be changed first. I'm going to place 5 of these and set them at an equal distance. Then I can change the airflow to make sure I meet the airflow demand. I can see now in my schedule on the right that both supply and return meet the required specified demand. So I'm going to fast forward while I do the same for each space in this project. Note that in the storage and mechanical room, since I don't have a ceiling, I probably needed different kind of terminal, but to keep things simple, I will just use the same for all spaces. Once done, I can double check the space schedule if specific airflow value match the actual airflow. Now I need to load a fan coil unit. I go up here to insert, load family. In my MEP folder I need to find terminal units, and the only family that has the right connectors for a 4-pipe fan coil system is this one right here. For the cell space I need the biggest unit, which is 4000 CFM. I want to set it to an elevation higher than the ceiling, which I know it is 15 feet tall. Using space I can flip it around, and while selected I will type BX to open section box. Here in my 3D view I can now use a line to attach it to the ceiling. Also back to plan view, I'm going to go to edit type and I will set all air connectors to 24 inches. At this point I can use create similar, and for pharmacy area I need almost 900 CFM. So from type selector I will select the one that says 1000 CFM. I need to flip it around to match connectors to the right type of airflow and set the right elevation. One more thing I need to do is to change the air connectors, and I'm just adding some random numbers. Obviously these dimensions would be determined according to the manufacturer specifications. For zone 2 I need about 1400 CFM, so I will choose the 1600 CFM fan coil unit, and I will just place it at 18 feet and 5 inches, just like the other ones. Flip it around and setting the dimensions for air connectors. Going back to my sales area, I will select the supply terminal and click on the duct. This will prompt create duct system window. It is a supply air system type because the connector on this is set to air supply, and I will name it make supply air 0. I need to check open in system editor, and now I can add the other 4 diffuser to the same system. Also I will go to select equipment and choose FCU. Now I can check OK to finish. I will do the same procedure for return air diffuser. Go to duct, change the system name, check system editor, and add all the return diffuser in this area plus the zone equipment, which is the fan coil unit. If I look in my system browser and I choose systems, I see 2 mechanical systems, and from here I can keep track on my systems. I will fast forward while I create systems for return and supply for zone 1 and 2. Once I'm done with that, I'm also ready to generate automatic layout. But before I do that, I need to figure out the elevation of the connectors. I'm going to select the fan coil unit and click on the air supply symbol to start routing duct, and once I do that, I can see the elevation of the connector up here. I'm going to copy this value, hit escape a couple of times, and then also check elevation for the return connector, which is 19.6, easy to remember. Now I will hover the mouse over one supply diffuser and hit tab till I see the dashed line area, which it means I'm selecting the system, and hit generate layout. Seems that Revit does not have any layout suggestion for me in this view, but if I change the view from ceiling to regular plan view and set the view range for elevation to unlimited, now I can see and select the system, and if I go to generate layout, I see that now Revit has some solutions for me. Before I choose solutions, I need to go to settings to set up my routing preferences. For the mains, I can choose the type of the duct I need to use for this system, and here at elevation I will just paste the elevation of the supply connector. Now I can also change preferences for branches. I will use the same elevation and make sure I have flex duct type assigned, and also I can set up a maximum length for flex duct. And I can also alter the proposed layout by going to edit layout. Here I can select this main and drag it to the right. I can also do the same to match on the bottom side. Now I will hover my mouse pointer over a return diffuser, select the system, go to generate layout, choose settings, set the elevation for the main to 19.6, choose the duct type I need, and also do the same for the branch. Here I also have to match the elevation, and also I need to make sure I don't forget the flex duct. I will also use edit layout to push this main line a little bit to the left. While I do the same for the other system zone, I will fast forward. When I'm done, I can go to my 3D view, uncheck the section box so I can see everything in my project. For chilled and hot water, I need to bring in my model some equipment. And if I look for my system loads and sizing report, I can go to equipment summary, and here I see the capacity I need for chiller, and for the chiller I will use an out-of-the-box family from Revit, look for chillers folder, and choose the scroll chiller air cooled. Also I have the capacity required for boiler. And again I'm going to load another family, look for the boiler folder, and I will choose this hot water boiler. Last thing I need is a pump, and I'm gonna scroll down till I find pumps. Here I see how many gallons per minute I need for each pump. Again, I will just use some default Revit families in the pump folder and choose this base mount pump. Now back in my plan view, I can now place my equipment, and this pump is too much for my system, but let's just go with that. I will place one here, flip it around using spacebar, then place one more right next to it. At this point I'm going to look for the boiler, and I will choose this one that it is rated 500,000 BTU per hour. And if I don't have the actual family from the manufacturer, these out-of-the-box families are very flexible and editable. They have some type parameters that can be customized, along with some instance parameters like output and input heat and others. So I'm going to place my boiler here in the mechanical room, Hit escape to clear my selection and then look for the chiller. I will place the chiller right here.